Okay, another way to think of multiplication is using a process called partial products. This method is just meant to illustrate how multiplication of a number is really broken into different sections that you're doing separately. So whenever I think of partial products, if I'm doing like 365 times 5, I'm really going to be multiplying each group by 5 separately. So if we think of this drawing right here, it's kind of like this is how much this column's worth. Everything in here is 300. This is 60. This is 5. This is the number of times I have it. So like if I would draw this out and split this into 5 sections, each section in here is worth 300. Because in multiplication, I'm literally having this number that many times. This section's really 60. And this section is really 5, which I have 5 times. So whenever I'm showing partial products, really I'm thinking that, hey, I have this top number that many times. So if I look at the box again, I don't need to break it up into sections. I just look at it and say, hey, in this section, I have 305 times. In this section, I have 65 times. In this last section, I have 5 times. So when I'm trying to solve using partial products, I'm just going to be multiplying the column, what the column's worth, and how many times I have that number in that column. So I have 305 times, I have 65 times, and I have 5 times. This up here is my distributive property representation of this multiplication problem, because I'm multiplying 300 times 5, 60 times 5, and 5 times 5. Now I can actually solve it, and I can do a lot of mental math here, because I know 5 times 3 is 15, 2 zeros, plus 5 times 6, 30, add that 0, plus 25. And then I can quickly add this. This is 1,500 plus 300 is 1,800, 1,825. That's how you would use partial products to multiply it. Now, I know multiplying with the single-digit algorithm is quicker and more efficient, but we want to think about how we can break this into pieces, because later on it moves on to algebra, and it'll help you understand how like 2ab plus a times 6 is the value that it is. But if I go through and multiply this, you'll see where we get each section. 5 times 5 is 25. So that's right here. And then I do 5 times 6 is 30, 32. So you see the 30 here, and I'm putting the 30 in the tens place. So it really has a value of 300. And when I add the 2, I get 320. And then I do 5 times 3 right here. You see how it's over in the hundreds place here? See how this has 2 zeros? That's why it goes there. 15 plus 2 more is 18. And I got the same answer in both problems. So it's just another way of thinking about it. And applying the math in a different way. And just to show you how this will lead to algebra in the future, if you have 2a plus 3b plus 4c, and you're timesing this quantity by 6, basically you can break it up, and I have 2a 6 times, so here's my distributing of this algebraic problem, and then I'll have 3b 6 times, and then I'll have 4c 6 times. And then I can simplify it. That would be 12a plus 18b plus 24c. Now this is more like 7th grade level work, but it's showing how understanding how the multiplication is distributed will lead later on into something more important and more abstract.